Hello students! So today I am going to discuss to you the last part of our lesson regarding uncertainties and error analysis. So from the previous video, we end up on the approximation of the second rule, that if you are going to add or subtract, you need to report your answer into the least number of significant figures based on the data given. So for the third rule, if a number raised to a power, either fractional or not, you need to multiply the relative uncertainty by its power. So for example, the mass of a cubical object is 235.1, positive or negative 0.1 grams. If a side of the object measures 5.25, positive negative 0.05 centimeter, what will be the density in grams per centimeter cube? So to solve this, we need first to get its relative uncertainty of each given. So we have the relative uncertainty of mass. So you are going to divide the absolute value to its measured value of mass times 100. So the answer will be 0.042535091.5%, or approximately 0.043%, following the two significant figures because it is lower than 2%. Next, on this relative uncertainty for the sides, we divide 0.05 to 5.25 times 100. So your answer is 0.95238952%, or approximately 0.95%. So it is still two significant figures because it is lower than 2%. Now, to get its measured value of density, you are going to follow the formula of density, mass divided by volume. So your mass is 235.1 grams divided by 5.25 centimeter raised to the power of 3. So your answer is 1.62470576 grams per centimeter cube, or approximately 1.62 grams per centimeter cube, following the least number of significant figures in the measured value. So the relative uncertainty in density will be added based on the rule. So your original percent uncertainty of mass plus 3, because in density your volume is in power of 3. So therefore yung 3 will be multiplied to 0.95238952. So your final answer will be 2.89967795%, or approximately 3%. Since it is greater than 2%, you need to estimate it into one significant figure. So therefore, your total relative uncertainty in density is equal to 1.62 grams per centimeter cube, positive negative 3%. So to get the absolute uncertainty in density, you are going to use the given relative uncertainty in density times the original total measured value divided by 100. So 2.89967795% multiplied to 1.62470576 grams per centimeter cube divided by 100. So your absolute uncertainty will be 0.04695539965 grams per centimeter cube, or approximately 0.05 grams per centimeter cube. So your total absolute uncertainty in density following the number of significant figures will be 1.62 positive negative 0.05 grams per centimeter cube. Next, in number 4, For a number to be multiplied by a constant, multiply the number and uncertainty if it is absolute. Only the number is multiplied by the constant if the uncertainty is relative. So for example, the length and width of a rectangle are 6.5 positive negative 0.1 meters and the width is 3.4 positive negative 0.2 meters respectively. Find the perimeter and area of the rectangle. So to get the perimeter, following the formula, P is equal to 2 times length plus width. So the perimeter is equal to 2 times 6.5 positive negative 0.1 meters plus 3.4 positive negative 0.2 meters. So you add first the measured value, so it is 9.9. Then add also the absolute value, which is 0.3, and multiply it by 2. So your answer will be 19.8 positive negative 0.6 meter, or approximately 20 positive negative 0.6 meters. Now the area of the rectangle is equal to the product of its length and its width. The absolute uncertainty must be converted to relative uncertainty. So refer to rule number 2 of calculations involving the data with uncertainty. The final answer must also be rounded off. So in your relative uncertainty of the length, 0.1 meter divided by 6.5 meter times 100. That is 1.53846254%, or approximately 1.5%. For the relative uncertainty of width, 0.2 meters divided by 3.4 meter times 100. It is equivalent to 5.88235294%, or approximately 6%. So the sum of the two relative uncertainty using the original percent uncertainty is equal to 7.42081548%, or approximately 7%. Now, to get the area, you need to multiply the measured value of length times its width. So your total area will be 6.5 meter times 3.4 meter is equivalent to 22.1 meters squared, or approximately 22 meters squared. So the total relative uncertainty is 22 meters squared positive negative 7%. Now to change percent uncertainty back into the absolute uncertainty, first you need to change the percent into decimal by dividing it by 100. And then you multiply it with the calculated value. So for example, if your original relative uncertainty is 22.1 meters squared positive negative 7.42081548%, to compute that, you multiply the percent uncertainty to its measured value and divide it by 100. So it is equivalent to 1.64001482 meters squared, or approximately 2 meter squared. So meaning to say the total relative uncertainty of the rectangle is 22 positive negative 2 meter squared. Any questions? Do you have any clarifications? If you have, you may PM me on Messenger or Edmodo. So if you have no clarifications, you may now start answering the exercises in your 12Ph-V-1.4, which will be attached in your Edmodo account later after you have done watching the video. So for further clarifications or questions, you may PM me in your Messenger. Your activity 1.3 will be attached and answered if most of you watch and understand the video. You may click the like button if you are done with the video. So thank you and God bless.